Hello everybody, just Mr. Willis here again for a second day of maths with line graphs. Now, yesterday we were reading and interpreting graphs, but today, as you can see, we are doing the following. We are drawing line graphs with accuracy, okay? And accuracy means we are going to try and be as accurate as possible when we draw them. So not drawing them as quickly as possible, or for example, not using rulers to connect the different parts of our graph. Using a ruler, a pencil, and where possible, squared paper. Now, there will be a link to squared paper that's been shared with you before by Mr. Kaywood. Let me just get that right. Sorry, Mr. Kaywood. But there will also be a link here as well, where you will find that at the top with a link to a printable squared paper resource. There is also a second printable piece of paper, but that's for later on, only if you choose to do the very final challenge, which is quite tricky, but that's entirely up to you. Now, so we're going to be drawing line graphs. Let's have a look at this then. I hope you've got all of the equipment you need, and let's move on. Right. First of all, we're going to start with a little bit of a problem here. Now, there is a graph. Now, this graph shows the distance a car has traveled, and you can see there the distance traveled in miles from 0, there's the 0 there, and it goes all the way up to 35 miles there. Now, there is here time in minutes, because we know that with along the x-axis, we know that with a line graph, always the time is along the x-axis. Notice as well that the graph is not complete. There is a missing part to it in the middle. Now, our problem, let's have a look at that in just a minute. Let me just this. Okay. Now, okay, here we are. Where are we? There we are. So, Kim and Roy basically were asked to complete the graph to show the car had stopped. Here are their completed graphs. Here is Kim's graph. And here is Roy's graph. Now, you will notice that they are slightly different. They have completed the graph. I'm just drawing in those sections. But I think we can probably gather there is a slight problem with this. Who has drawn the graph correctly? Well, let's just open this up a little bit more to make it bigger so we can see both. We will be getting rid of those. Right. So, first of all, let me just hide this out of the way. We have the graphs starting normally and continuing. There they are up to this point here, which is, as we can see, 25 minutes. And then all of a sudden, the graph starts again on the other side. Now, Kim has said that, well, actually, I just joined this point to this point, and that what's happening is there isn't any further distance traveled, okay? And that here, actually, Roy has said, well, actually, no, what happens is there isn't any further distance traveled, but actually it drops all the way back down to 0, and actually there isn't any distance that has been traveled overall. Okay, so my first question to you is this, and I'm just going to go back here. Who has completed the graph correctly, and can you explain how you know? I'm just going to give you a couple of minutes to do that, and then when you've finished, can you please return to this? Thank you very much. Thank you very much. So, okay. Who do we think is correct? Well, actually, I'm going to explain now. Actually, we will find that, or you will find that, it is in fact Kim who is correct. And the reason Kim is correct is actually quite straightforward. When it stops here at this point, which is 25 minutes in, so after 25 minutes, there is a break in the terms of the distance that's been traveled. And the distance that's been traveled so far is 15 miles. Now, what you'll notice is that here, all of a sudden, all those miles that Rory is saying had been traveled, when a car's traveled, whoop, suddenly go to 0. And it hasn't traveled any miles. But of course, it must have traveled It's still traveled that distance. So we can't get rid of those 15 miles. They're still going to be there. And therefore, we must connect across because those miles must remain there. They have been traveled. They're not imaginary miles. So in fact, actually, Rory, you are wrong. Okay. And Kim, you are correct. Now, the reason I've included this problem is because what it's actually doing is showing you that we do need to be accurate when we draw our graphs. Okay. Now, that's why we need to be able to draw line graphs correctly, because we could end up like Rory. So I've got a question for you. Oh dear, what's happened here? Let's just get rid of this. What are the potential problems when drawing line graphs? Can you please answer that on your Google form below the question you've just answered before? And I'll wait here for you. Okay, so what are the potential problems when drawing line graphs? Well, there are a number of problems. If we go back to what happened previously, if you just excuse me there, go back to here, we can see what has happened. And actually, it's probably easier to go back to this one here. Where are we there? We can see what happened with Rory. Rory made a mistake and it completely changed the nature of the graph. That means it completely changed what the graph looked like and what had happened. We can suddenly create large mistakes, which makes it very, very difficult for somebody reading our graph to understand what has happened. And they may be very confused by the data we're trying to interpret. Okay, here's another question. Which skills will we be needing in this lesson? Okay, very quickly, complete that question on your Google form and then come back. Okay, so, right. You've paused it, you've come back, right? You've answered that question, hopefully. Let's have a look. These are the skills we will be needing. We are going to need to do the following. And I'm just going to go through this because this is the easiest way for me to explain it. When you think about a graph, the first thing is you're going to have to determine a scale. All right. Now, the scale means it could be the x-axis or the y-axis. Now, if we go back to here, and if I just get rid of these, and I'm just going to use Kim's graph, I don't really need to do, I'll just get rid of all of this. There we go. You are going to need a scale for this part here. So you're going to need a scale for your y-axis and whatever the data is. In this case, it's distance in miles. You are also going to need a scale for your time. And in this case, it's minutes along sorry, that was the y-axis, should I say. I hope I didn't say x-axis. But along the y-axis, that's the data, you will need a scale for the number of miles. In this case, she's done 1 square is every 5 miles. Now, likewise, you're going to need the same for time in minutes. You're going to need a scale here. We're doing time minutes. She's done every 5 minutes. Okay, so there you go. Every 5 minutes is a new interval. So that's how she's done it. Now, it has to be easy for the reader to read your graph and understand that particular scale. So we need to start with the horizontal scale, y-axis. Okay, that's not the y-axis, that's the x-axis, in fact, because I'm reading it incorrectly. It is the x-axis, that's the time. You're going to start with a time scale. What is the greatest value and the least value for the first set? I would not even draw a line at this point, okay? Don't draw the line, just put a point in the corner of the paper, and there is a diagram on how to draw that in a moment. There is not a diagram, sorry, a video later on, and there's 2 videos. You can choose which one you want to watch, and it will go through it. Please, I'm going to read all of this to you. Please listen carefully. What is the greatest value and the least value for the first set? You are going to have to work out the greatest and least value for the first set. There might be more than one set of data, okay? So you might have to think about that. What is the greatest and the least value? Smallest and biggest. Determine whether the greatest value will fit on the graph. So think about your paper, if you're using squared paper or you're using a ruler to measure centimeters for each interval. Think about that. If it doesn't, then change the scale and try again. Then do exactly the same thing for the y-axis. You've done the x-axis, the time, then you're going to do the data. And the scale is really important before you start drawing your graph. Next, label the graph. Really important this. Mark each unit across the horizontal scale and along the vertical scale. They must be represented. You must have numbers, okay, that represent the time and whatever scale you're using for the y-axis. Plot the points and connect them. So then what you do is you plot the points, and again, this is all explained in the videos below. plot the points, and then you connect them using a ruler with straight lines. You will need a ruler for this. If you don't have a ruler, use the straight edge of something like a book. I don't know, whatever you can find. Give the graph a title. You have to give the graph a title, explain what it is about. Right. Okay, I'm going to move on very quickly. So there are two videos. Here's the first video. This is a faster video. Okay, if you are already pretty confident with drawing line graphs or feel you are pretty confident being accurate with them. Here is one on paper. This is a longer video, but it does explain very clearly how to do it. Now, it is designed for a year 4 class because I've made it deliberately easy, okay, because you do start doing line graphs in year 4. So this is the second video. You don't have to watch both. You can choose which one you want to watch. It's entirely up to you. So what I'm going to ask you to do now is pause this video and then come back to it after you've watched one of those videos, please. Okay, let's move on very quickly. So next thing, I am aware that this video is taking a little bit of time, and I'm sorry. I did say I would try and cut this down today. So I just want to go through the problems. Next, these are the problems. There is a question here. Please answer all parts of the question. When it says, can you make up 3 questions about this graph? Please do make up 3 questions after you have completed the graph. Here is a checklist for you. And afterwards, there is a checklist for you to go through to make sure you have done that. Now, next, move on to the next one. And these are all on the Google form, okay? Just go through each one on the Google form, plot the graph, and they're supposed to be done on paper. This one is on paper. This one is on paper, okay? Again, make sure you do the questions. You check, okay, that you have all of these. There's also a bonus yellow point just to check. And there you are. There is the checklist. First 2 questions done. Third question is slightly different. It says you complete this question with the data using, okay, this graph, creating a graph link. Now, this is above, it's at the title above this slide on the Google form. You will see that link, and then you can do that digitally online. So you don't need to draw that one on paper. And there is a checklist to check that you've got that right. And then finally, if you want, it's entirely up to you. There is a challenge question, but the challenge question requires scientific paper. Now, I put a link on again above this section, and it explains there. Sorry, above this section here, and it has a link to scientific paper. So you can print that out if you want to have a go at it, because you probably will need it unless you can find some other way of doing that. Right. Okay. Sorry that this took so very long. Please take care with this. Accuracy is really important. Thank you.